This question will check your knowledge of the quadratic formula, revise reflection symmetry, and explain how to find the equation of a reflection. To sketch the quadratic, first find the X-intercepts, which occur when y equals 0. Substitute y equals 0 into the quadratic, and solve using the quadratic formula. Compare the general equation of the formula with your quadratic to find the values of a, b and c. So a equals 4, b equals negative 40, and c equals 100. Substituting these values in the formula to give minus negative 40, plus or minus the square root of negative 40 all squared, minus 4 times 4 times 100, all over 2 times 4. Working out the brackets first gives 40 plus or minus the square root of 1600 minus 1600 all over 8. The square root comes to 0. So x equals 40 divided by 8, which is 5. So when y equals 0, x equals 5. And the curve touches the x-axis at 5, 0. Which is plotted on the sketch. But to draw the graph we need the y-intercept, which occurs when x equals 0. So substituting x equals 0 into the equation gives y equal to 100. So the y-intercept is the point 0, 100, which is plotted on the sketch, and the curve can be drawn. Now we're going to find the equations of the reflections, and we start by reflecting in the x-axis. Each point is the same distance below the axis as it was above. Notice that any point xy, when reflected, becomes x negative y. Since the y-coordinate becomes a negative, substitute y for negative y in the equation. This is the same as multiplying each term by negative 1. So y equals, so 4x squared times negative 1 gives negative 4x squared. Minus 40x times negative 1 gives plus 40x. And 100 times negative 1 gives minus 100, which gives the equation of the reflection. It is always a good idea to check your answer. These checks could be done in your head. The y-intercept is when x equals 0. So substitute x equals 0 into the equation, giving y equal to negative 100. And the y-intercept 0, negative 100, which is correct. Now check the x-intercept, which is when y equals 0. So substitute y equals 0 into the equation and use the quadratic formula. Our reflection touches the x-axis, so we know the square root of b squared minus 4ac equals 0. You might want to check this. So the formula becomes x equal to minus b over 2a. Substituting b equal to 40 and a equal to negative 4 gives negative 40 divided by negative 8. Which is 5. So the curve touches the x-axis at 5, 0. Checking the graph, we see this is correct. Now reflect in the y-axis. Any point xy becomes negative xy. So substitute x for negative x in each term of the equation. So y equals 4x squared plus 40x plus 100. So the equation of the reflection in the y-axis is found. Now the check. The curve cuts the y-axis when x equals 0. Substituting x equals 0 into the equation gives y equal to 100. So the y-intercept is 0, 100, which is correct. And now checking the y-intercept, which is when y equals 0. Substituting y equals 0 in the equation and solve using the quadratic formula. Again, we know that b squared minus 4ac equals 0. So x equals minus b over 2a. Substituting b equal to 40 and a equal to 4 gives negative 40 divided by 8, which is negative 5. So the curve touches the x-axis at negative 5, 0, which is correct. Now reflect in both the x and y axes. We could reflect in the y-axis first, followed by the x-axis, giving this result. Note the image of the point. Or we could reflect in the x-axis first, followed by the y-axis, giving this, which gives the same result. So this curve gives the reflection in the x and y axes. The image of the point xy is negative x, negative y. So substitute negative x for x and negative y for y in the equation. Then work out the brackets to obtain negative y equals 4x squared plus 40x plus 100. Then multiply every term by negative 1 to obtain y equals negative 4x squared minus 40x minus 100, giving the equation of this reflection. To check, first find the y-intercept, which occurs when x equals 0, substituting x equals 0 into the equation, giving y equal to negative 100. So the curve cuts the y-axis at 0, negative 100, which is correct. Now check where the curve cuts the x-axis, which is when y equals 0, substituting y equals 0 into the equation, and solve using the quadratic formula, where we know the square root comes to 0, giving x equal to minus b over 2a. Substituting b equal to negative 40 and a equal to negative 4, which gives 40 divided by negative 8, which equals negative 5. So the curve touches the x-axis at negative 5, 0, which is correct. We have found the equations of all the reflections. In this video, b squared equals 4ac, so the square root of b squared minus 4ac comes to 0. So there is only one value for x, and the curve touches the x-axis rather than intersects it.